Добрый день, меня зовут Yunfeng Bai, я из Китая, но такой области, научной области русского языка я плохо знаю, и вот почему я буду говорить по-английски, и простите. And today I'm going to talk about our new research, our new work, which named Rock image super resolution where deep convolutional neural networks based on high performance pre-processing. And I'm going to talk about with 5 parts. First is the research background. Second is the basic conception. And the third, proposed method. And after that, I'm going to talk about with the experiment. And in the last part, I'm going to make the conclusion. First, the background. Desktop rock physics is a method to construct the desktop rocks with geological idea by modern mathematics and computer technology. Then simulate the physical fields, calculate equivalent physical parameters, and finally study the relationships among the microstructure and material phase and the micro-equivalent property. And during this process, it's need to prepare the high-resolution images. And here are some images of the digital rocks. Based on, according to the idea of that, based on these images, we can calculate the parameters of the oil and gas department which they need. And based on this, in order to tell about our method, I need to introduce some basic conceptions. And first, I'm going to talk about the convolutional neural networks for super resolution. And this is a deep learning method which was proposed by Zhao Dong in 2014. It was the first deep learning method to prepare the super high resolution images. And after this method was proposed, and it have been popular in many image area. For example, a lot of researchers used this method to enhance the medical images, radar images, and underwater images. And this method was divided into 2 parts. First, these images were decreased to desired size with the cubic interpolation algorithm. After that, they put these image pairs into the neural networks. And after learning a lot, and the neural networks has magic power, and they can enhance the low resolution images to the high resolution images. And in our work, we want to use a method, but we didn't directly use this method. We improved the first part of this method. And in order to understand what we have done, I need to introduce these basic conceptions. First, bilinear interpolation. When the image is enlarged or reduced to another image, the number of pixels need to be increased or decreased. And the question is how to calculate the value of these pixels. And bilinear interpolation is a very popular method and the to be interpolated pixel is found with this algorithm by using the four nearest pixels around this one, and the formula is this one. And this is the basic method. And another popular method is the cubic interpolation algorithm. And this algorithm is also very popular when the speed is not the key issue. But as the digital rock, later we want to expand this method to three-dimensional. And so the issue is the speed is very important for us. So we need to improve this method to make it fast. And here is the bicubic interpolation algorithm, and it uses 16 pixels to calculate. This is the green one is the pixel we want to calculate, and these are formulas, and this method is based on these 16 pixels to calculate this one, and this is standard one, but usually this method takes a lot of time. So in previous work, some other researchers invented a method. They combine these two methods together for the pixels which want to need to calculate. They meet this situation when the variance is smaller than, for example, some thread, and they use the B-layer interpolation to calculate the value, and for the other part, they still use this one. So based on this idea, they saves almost 10% of the time. And later, in our previous work, we found this method can save 10% of time, but it's not very fast. Then we found in some situations, a lot of calculation are repeated. So first we rewrite these formulas into these ones, and first we calculate, and the process of these formulas can be seen as this. First, to calculate with these blue pixels, to calculate these yellow pixels, and these yellow cells, in fact, they are not excited. They can't excite. And after that, we use these yellow pixels to calculate the green one, which one we need to calculate. And so we found from these images, after in some situations, these two yellow pixels are overfit. So we rewrite these formulas into these two formulas, and we put this process into two parts. First, calculate all the yellow pixels as some media image, and after that, based on these media images, to calculate the images we need. And in previous work, we have proved when the maximization features larger than 1/3, it can be used this method to the yellow pixels is going to be calculated repeatedly. And so for the super resolution questions with deep learning, the magnificent letter is usually 2 of 4, so it's meet this situation. And yes, and we avoid to calculate them rapidly, so it's stable. In our previous work, we prove it almost save 16% of the time compared with the standard bicubic interpolation algorithm. And after that, we found in this work, we found that these two methods, the two ideas still can combine to use together. First, for the variance is smaller than 3, and we use the bilinear interpolation to calculate this part, to calculate the yellow part. And for the other area of the images, we use the space for time algorithm, like this, still like this. And after that, we found that we write our code to test the performance. We use the 50% of we use 50 images to test it, and these images are 72 by 72 pixels. And for when the images are increased by 2, and we found that this is the time we need for our proposed method. This is the space for time strategy, which we have talked about in the second algorithm. This is the first algorithm we have talked about, and we found that our algorithm is the fastest. And when the situation is 4, and we also found our algorithm is fastest, and the speed up are in the when the micro factor is 2, and it's 1.54, and compared with this one, the speed up is 5.01, and this is the speed up is like this. So we can find our proposed method has a high performance. And after that, we followed the standard. Process of the deep learning. We put these data sets into the models, the neural models, and to training. And then we found that our method, based on our method to training the process the images, our method is not influences the performance of the result of the PSNR. So we found our method is useful, I think. So now I'm going to make the conclusion, and compare with other two algorithms. Our approach indeed saves time, and later we are going to expand our method to the 3D dimensional, and I think it can save even more time, and the speed up will be even more, I think. That's all I want to say. Спасибо большое. Спасибо за внимание. И